Stoichiometry. Now we're going to start getting into the amounts of stuff in chemistry now. And stoichiometry, the word itself, comes from the ancient Greek, which is the measure of the elements. The Stoics were very keen on measuring things around them, measuring their universe. So the starting information and skills you're going to need are the skills to be able to write formulae for compounds. If you can't write formulae, you can't write equations, you can't balance equations, and you can't work out quantities. Now, there's lots of different methods for working out how to write formulae, and we'll talk about a few of them in a minute. But there are some formulae that it's worth you just sitting down and learning. I would suggest that you find the chemical formulae of the chemicals, the compounds indicated on these lists, and write down their formula and memorize it. And at some point we'll have a test or a quiz to make sure you've got them. Some of them you can work out, but it's better just to learn them off by heart at this point. Naming of compounds. Now this we've mentioned before. If you've got a metal and a non-metal, then the name of the metal is given first, and the non-metal on its own would be an ide. It changes to ide. So sodium chloride, magnesium oxide, zinc sulfide are three examples of that. You will see sometimes the ending 8, and when you see the ending 8, it refers to a combination of the non-metal with oxygen. We'll talk about that more in the future. When the compound's made up of two non-metals, then the rule is if one of them is hydrogen, it's given first. Otherwise, the non-metal with the lower group comes first, and then the name of the non-metal with a higher group has got ide on the end. Examples: hydrogen chloride, the hydrogen comes first. Carbon dioxide, carbon is in group 4 and oxygen in group 6, so carbon comes first, carbon dioxide. Valency, we've mentioned this before, you know the definition, but just to remind you, the valency is the number of electrons an element's atoms lose, gain, or share to form a compound. So let's have a little look at some common examples so you've got them and you know how to work them out. Group 1 metals, lithium, sodium, potassium, etc. When they form compounds, they always lose one electron. Their valency is 1. Group 2, beryllium, magnesium, calcium, strontium, and barium. They lose 2 electrons. Their valency is 2. Group 3, they lose 3 electrons. They have a valency of 3, and the clear candidate there to always mention is aluminium. For group 4, obviously you've got carbon, silicon, germanium. They will never lose or gain 4 electrons. They will always share electrons to form covalent bonds, but their valency is 4 nevertheless. Group 5, nitrogen, phosphorus, they can share or they can even gain 3 electrons, but that gives them a valency in both cases of 3. Group 6 will share or gain 2 electrons to get a full outer shell, so their valency is 2, and oxygen and sulfur are the examples. Group 7, fluorine, chlorine, bromine, iodine, etc. They will share or gain 1 electron to get a full outer shell, so their valency is 1. The noble gases, well, they don't lose or gain electrons, so it's not applicable, and their valency is considered to be 0, which might be why they're called group 0. Anyway, and hydrogen will lose, share, or gain 1 electron. Its valency is 1. And transition metals, they can lose 1, 2, or 3 electrons. In the case of copper, remember, you can get copper +1, copper plus, or copper 2+. In the case of iron, you can get Fe2+ and Fe3+. Now, we can use this information and these valencies to write formulae. So there's a simple trick here to write formulae. So if I take, for example, aluminium oxide, aluminium's got a valency of 3 and oxygen's got a valency of 2. So what we do is we swap their valencies. If possible, we cancel, but we swap their valencies. So aluminium is 2, because that's what oxygen's was, so they swap, and oxygen is 3, Al2O3. Another example, aluminium phosphide. In this case, aluminium, obviously, valency of 3, phosphorus, valency of 3. They swap, so they both get 3, Al3P3. But in this case, they can cancel. So you've got Al1P1 or simply Alp. Charges. We've seen charges before. We've talked about ions. So this is a list of the ions that you should know off by heart. You should know these ions off by heart. And then we can use these ions to form chemical formulae. So we'll use them in a second. But these, you should know them, and you could be tested on them at some point in the future.